not need to memorize these models. So if you remember, A of t equals P e to RT, this is the formula for the interest compounded continuously, right? Interest compounded continuously. It will be given to you. Last time we looked at A of t equals A0 e to kt. As you see, it's identical. It's just that these represent something else. This is the original, like the principal is the original. This is the growth rate, like the annual interest rate. T is time in years. And this is the amount. So this is the exponential growth model. The one we're going to finish this chapter with is this. What's the difference? Just a negative. And this is the exponential decay model. Exactly. And the other formula, again, none of these, only these will be given to you. And the other one was for the interest compounded n times a year, which is different. So these are the only formulas from this chapter. Is this okay? Okay, so let's start with the exponential. Let's continue with the exponential decay model. Okay, so here it is. An artifact originally had 16. So these are problems 15 and 16 on page 529. Originally had 16 grams of carbon 14. The name of the radioactive substance is not important. So 16 grams of a radioactive substance. Okay. The decay model is A of t. Notice that the book does not write A of t. They don't put t in parentheses. I think it's a mistake because t is the variable, and I don't want you to get confused that there is something else in there. Everything else is a constant. So A of t equals A0 e to negative kt. So this is a constant. This is the independent variable. This is a constant, and k is a constant. K is the decay rate. A is the function. T is the independent variable. And this A0 is the initial. Initial, in this case, is initial mass. In the previous model, in the exponential growth, it was the initial number. Okay, so let's see what we are asked to determine. And here's the model. They are giving us the model. So A of t equals 16 e to negative 0.30 121t describes the amount of carbon-14 present after t years. We know that. How many grams of carbon-14 will be present? So this is 15. In 5,715 years. And number 16, they want after 11,430 years. So what am I really asked to do? I'm asked to find what is the amount of carbon-14 after 5,715 years and respectively 11,430 years. So what am I asked to do? What do I do for this? Exactly. So that's why I would like you to understand that this is a function of time, which is t. So this is clearly, as you see, this is clearly what? The original mass, the initial mass, or the original, correct. This is clearly what? The decay rate. And of course, time is t. So for this, I have to find A of 5,715, and for this, A of 11,430. So let's put this in the graphing calculator, please. Because I don't want to repeat I don't want to repeat the calculations, although it's fine. I highly recommend putting the function in y equals 16 e in parentheses negative 0.30 1 to 1x, close the parenthesis. And then we go to second and table, and we put in 5715 and 11430. And you see the y value, or the function value, is 8.0131 grams and 4.0131 grams. Now I want to add a question here for you. When will the initial mass of radioactive substance will be half? What do I mean by half? Exactly. That is called the time, it's called half-life. When the original mass is divided by 2. So when the mass becomes half of it, of the original. So then I'm asked when. So find the time for this carbon-14 when any amount will be halved. So how do I continue? What do I write? What do I need to solve?
The A of T is
Yes, how much? How much is it?
8.
Exactly. So 8 equals 16 e to negative 0.00121 t, when A of t is 8. Exactly. And we want to determine time, t. Now I have to look at this and ask myself, okay, wait a minute, what type of equation is it? Because if you say absolute value, we'll do one thing. If it's linear, something else. If it's quadratic, something else. If it's quadratic in form, something else. If it's rational, what is it? It doesn't have a ratio. It doesn't have x in the denominator. So it's exponential because the variable is at the exponent level. The variable is nowhere else but inside an exponent. Awesome. Very good. So then what do I do next? It's not cleaned up. I have to clean it up first. What do I mean by that? I mean simplify. But what do I do?
Natural log.
Not yet. You are ahead of me.
Oh. 16.
Exactly. I need to divide by 16, so I have 1/2 equals e to negative 0.00121 t. Yes, now it's ready. It's ready for what? It's ready to apply.
Log. Natural log.
Exactly. So the left-hand side is natural log of 0.5. And the right-hand side is, I bring the power in front, negative 0.30121 t, and I should multiply by what? Times what? Times natural log e. But what do we know about natural log e? So I should write here times natural log e, right? Natural log e. So let's see how much is natural log e. What is the base when we talk about natural log? That's log. Look in the calculator. So log is base 10, and this is base e. There is no base of 1. Remember, no negative base, no 0, no 1. Okay, so what is the base here in natural log? Exactly. So e raised to which power is e? No, e to 0 will be 1.
1.
1 indeed. That's why I didn't write natural log e. In general, let's write this. Log base a of a. So log in any base you want of the base. A raised to which power is a? Exactly. So this is important to remember. Log and base 15 of 15 is 1. Log base 1/2 of 1/2 is 1. What about log base, any base you want of 1? Let's think about this. A raised to which power is 1? Very good. So log in any base of 1 is 0. Very good. Okay, so then I'm solving for t. All I have to do to both sides is I have to divide by this, both sides, to get t. Is that okay? So natural log 0.5. Remember, you cannot separate these two. They have to go together. Negative 0.000121. So let's put in the graphing calculator. And let's see when will the mass of this, any amount of carbon 14 will be halved. So natural log 0.5 divided by, don't forget parentheses, negative 0.30, 1, 2, 1, and close, and press enter. And 5,728 years, approximately. Okay, let's look at problem 17 on page 529. The half-life of the radioactive element krypton-91 is 10 seconds. This half-life. What does that mean? Let's say we have 100 grams of krypton-91. We shouldn't because it's radioactive. But it has its half-life is very short. Look at this one. The half-life, it needs 5,728 from 100 grams to become 50, right? But this one, from 100 grams, it becomes 50 in 10 seconds. From 50, it goes to 25 in 10 seconds. From 25, it goes to 12.5 in 10 seconds. Very fast. It disappears like that. Okay? So the problem is asking us to find if 16 grams of krypton-91. Yes, please.
I thought the half-life was based on the size.
No, it's characteristic to each substance. One substance needs 5,728 years to diminish from 100 grams to 50. Another one needs 10 seconds. It depends on the substance. The formula is the same, but every substance, every radioactive substance has a different half-life. Okay, so it says we start with 16, and they're asking us to find out how many grams are present after 10 seconds. So after 10 seconds, how many are present? Very good. After 8 more seconds, after 10 more seconds, how many? After 10 more seconds, how many? After 10 more seconds, how many? And they want 1, 2, 3, 4, one more. After yes. Very good. So that's the idea. Let's look at also, are we interested in, yes, paintings, number 19. That's a good one. So number 19 on page 530. Let's read the problem. Prehistoric cave paintings were discovered in a cave in France. We are given the same formula for carbon, A of T equals A0 e to negative 0.30 T. So we're back to carbon 14. We're discovered in a cave in France. The paint contained 15% of the original amount. So they were painted a long time ago. They were discovered. And somehow they measured the amount of carbon-14 existing today in their painting, in those paintings. And they measured and they said, okay, we don't know how much it was originally, but we can tell that right now only 15% remained. 85% just disappeared. 15% is left. So maybe from measuring how much carbon-14 they have today, we will be able to determine when they were painted, approximately. It may not be exact. So then, what do we mean by 15% of the original? And remember what I asked here. How long it takes for this amount, the 16 that was original, to become half of it, which is 50% of 16, right? But this is a slightly different question. So the original amount is A0. It's unknown to us. But right now we measure, and it's 15% of the original amount. What does that mean? How do I write something like this? 15% of the original amount. How is the original amount denoted? How do we denote the original amount? Say it again. No, this is what we have today. So from all this, which portion is the original amount?
A.
0. A0 is the original amount, right? So let's go back to our list of models, right? So A0 is the initial or the original amount. Initial or original amount. Good. But how do I write 15% of A0? Say it again. So I want something that represents 15 of A0. How do we write that?
A0 divided by
Not divided,
time.
multiplied. Yes. So 0.15 times A0 is 15% of the original amount.
Okay.
Good. So now create the equation for us, please. Anyone?
AT equals 0.15.
Right, but that goes in here.
Yes.
So 0.15 A0 equals A0 e to negative 0.000121 t. And now you can say, but you don't have A0. True. But what will you do to both sides of this equation? Yes? We simplify both sides. We have to clean it up. If we don't clean it up, we'll make our life way more difficult. I will divide both sides by A0 because A0 is not 0, right? So then the new equation is 0.15 equals e to negative 0.00121 t. And yes, of course, correct. We are applying natural log to both sides. And this is negative 0.30121 t. I should have written multiplied by natural log e, but I do not because it equals 1. Very good. Awesome. So final step is we have to solve for t. Yes, natural log of 0.15, negative 0.00121. So please plug it in the graphing calculator, and let's see what we get. So natural log 0.15, close the parenthesis and divide by, in parentheses, negative 0.30121, close the parenthesis. So they were painted approximately 15,679 years ago. And that was determined by simply measuring the existing carbon-14 in the paintings. Any questions for me? Any questions? Okay, now the next 3 sections should be a review. But we will go through them completely. Say it again. Yes. You want a copy of this? You want to copy this? But I think you should leave this till the end. I think you should pay attention to this, and then you can copy it. I can scan it and even give it to you. It's up to you. Okay. So I'm on page 4. Do we have 3 pages there? Joseph, do we have 3 pages there? Am I on page 4? Okay, perfect. Chapter 5. Chapter 5 deals with systems of linear and nonlinear equations and inequalities. Systems of linear, nonlinear equations and inequalities. I guarantee you that you will remember at least 60% of what we are reviewing right now. I have no doubt. Okay, so in 5.1, we are looking at solving systems of linear equations in 2 variables. Solving systems of linear equations in 2 variables. Anyone remembers the methods? They are substitution. So by substitution or by, it's called adding or elimination. Solving systems of linear equations in 2 variables by substitution and elimination. So let's take a look. Let's start with 14 on page 555. 2x plus 5y equals 1, negative x plus 6y equals 8. Can anyone tell us what is this? This. Linear. Good. So if you graph it, assuming you graph it, how will it look? Like a line. Very good. Awesome. So there are 3 possibilities. Possibility 1, when this line meets this line in 1 point. 1 solution. What else can happen? What is the second option? And what is the third option?
How do you type this fast?
95,
They can be what?
5,
Very good. They can be parallel. And how many solutions, if they are parallel, how many solutions we get? And how many points do they cross or meet? None. No solutions. Very good. And here's the third possibility. This is the first line, and this is the second line, which means infinitely many solutions. Nothing else can happen when we solve systems of 2 linear equations in 2 variables. These are the only 2 possibilities. 3 possibilities. Okay, so we're asked to use substitution. I will be looking at this original system, and I will decide which variable to solve for. I will not solve for this x because it has 2 in front, and I don't want to divide by 2. I will not solve for y because it has 5 in front, and I don't want to divide by 5. I will not solve for this y because it has 6, and then I will divide by 6, and it will be a fraction to worry about. I will definitely solve for x only because its coefficient is 1 or negative 1. Any questions on how we decide? So therefore, from the second equation, I will get x. So negative x equals negative 6y plus 8. I divide both sides by negative 1 or multiply both sides by negative 1. Just a linear equation, right? Now, I will replace x in the first equation by what I just determined from the second one. I determined that x equals 6y minus 8. So I will go back from the second equation. So I'll go back to the first equation and replace it in here. So this is then 2 multiplied by 6y minus 8 plus 5y equals 1. So all we did was just a simple algebraic manipulation that allowed us to create an equation with one variable, which we know how to solve. It's linear. So what will I have to do? Obviously, I will have to distribute, of course. Of course. So 2, so that's 12y minus 16 plus 5y equals 1. So 17y equals 17, so y equals 1. I know for sure that you remember part of this.
Yeah.
What about the negative sign?
Why did you go from 12y minus 16 plus 5y equals 1?
I don't know if I should answer questions on linear equations, but I will.
We combined it.
No, I know how you got 17y, but how did you go from it being equal 1 to 17y equals 17?
This is negative 16, and I have to move it to the other side to separate the variable from the rest. That's what I said. At this level, I shouldn't answer questions on, but I will. Okay, so is this good? Good, but not good enough. I have to go back and replace y and get x. How much is x? Negative 2. What is the prospect solution? We don't know for sure. I have to go back and check. But what is the answer for now? Negative 2, comma? Good. So I have to go back to the original problem and check. Negative 2, 1, negative 2, 1. I replace 1 in here. 6 times 1 minus 8.
Got it.
Good. So now let's go back. Negative 2 times 2 is negative 4 plus 5 is 1. Yes, correct. Negative 2 with minus in front is 2. 2 plus 6 is 8. Correct. So only now I can say, yes, I checked. Do we need another substitution, or can we move on to elimination? Yes, of course. Would you like to choose, or you want me to choose?
You got it.
Okay. So this was 14. Let's look at 13. On the same page, 555. And we have 2x plus 5y equals negative 4. And 3x minus y equals 11. We are asked to solve the system. How will I do this? By substitution. Will I substitute for this x? No, because the coefficient is not 1 or negative 1. Not for this y, coefficient is not 1 or negative 1. Same thing here. So I will definitely substitute for this y.
We're doing substitution again?
Yes. Oh, yeah, we want a substitution, right?
Yes.
Yes, we want a substitution. So this is what I would like to do. So 3x minus 11 equals y. Do you have to do this? No, but then you still have to multiply or divide by negative 1. It's up to you. What do I do next? So I use the second equation to get y by itself. I have to go back to the first one and replace y by what I just found out. I found out that y can be replaced by 3x minus 11. So then the first equation becomes 2x plus 5. 3x minus 11 equals negative 4. Let's stop for a moment and please let me know if this is okay. Everyone? Yes, everyone? Okay. So now we're back to what we've been doing 3 months ago. It seems like it. Minus 55 equals negative 4. Combine like terms. 77 equals 51. X, of course. 17, yes. I said 77? I'm sorry. I meant 17x. So then x equals 51 divided by 17, which appears to be 3. Is this good? Yes, it's good. But it's not good enough. Because I have to determine the ordered pair, right? So then 3 times 3 is
No.
9 minus 11,
Two, negative.
-2. So then the solution appears to be, I'm not sure yet, but it appears to be perfect. Thank you. So 3, -2, 3, -2, 6 minus 10. 6 minus 10, -4. 9 plus 2, 11. Yes. And then I go back and say, yes, this is it. We do have the method of elimination, which I personally prefer. I think it's most of the time more useful and easier, but not always, of course. Okay, ready? Let's start with 24.
Do an elimination.
Elimination now. So 2x minus 7y equals 2, and 3x plus y equals -20. So it's the same page, 555. Elimination. Okay, so in the elimination method, the following is absolutely mandatory. All terms have to be presented one below the other, x below x, y below y, the equal symbol below the equal symbol, and the free term below free term. This must be it. Now I'm going to discuss the coefficients, 2 and 3. If I want to eliminate x, then I will have to multiply the top by 3 and the bottom by -2. Why? Because 3 times 2 will be 6x, and -2 times 3x will be -6x. So 6x with -6x will go away. Let's see if there is a better or easier method. I see a -7 here and a +1 here. In order to eliminate y, I only need to multiply the second equation by +7. Why not? I don't want to multiply 2 equations if I can get away with multiplying just one. So I will copy the top one, and multiply both sides, each term, by 7. The second one, 21x plus 7y equals -140. And now I will add term by term. These two will give us 23x. We accomplished our target. We got to the target, meaning y, terms with y are gone. And then I copy the equal symbol, and -138. So therefore, from this equation, I have that x equals -138 over 23, which means -6. Is this good? Yes, it's good, but it's not good enough because I only determined x. Yes, Stephen, go ahead, please.
Substitute -x.
Exactly, awesome, yes. Anywhere you want, it doesn't matter. So let's say we go to the second equation. It doesn't matter where we go. So 3 times -6 is -18. So awesome. I see you remember this. It's great. So then we add 18, so y equals -2. The solution appears to be, we're not certain yet, the solution appears to be correct. Please do not trust it before you check. That's always the case. Yes, please.
Oh, never mind.
Which equation did you use? Okay.
I went back to the second one. If you go back to the first one, you will still get the same answer. Mandatory. So this is -6, -2, -6, -2. -12 plus 14. -12 plus 14 is indeed 2. -18 minus 2 is -20. Yes. So then I can guarantee that this is the correct solution. No one needs to tell me otherwise. We remember this, correct?
Yeah.
Yeah, but
Yeah, that's fine. So do we need another example? We just need to practice. We need another example with the elimination?
Let's do it.
Very good. Awesome.
I agree with that.
Say it again.
Sorry to repeat that.
Okay. Good. So let's take a look at, let's say 28. 2x plus 3y equals negative 16, and 5x minus 10y equals 30. Let's analyze which one we would like to eliminate.